Let us discuss the question about VSEPR for polyatomic ions. I have provided with 9 questions of the polyatomic ions. In these polyatomic ions, you have to draw the structures and also to tell the number of bond pairs, number of lone pairs, the angle, and also the shape of the polyatomic ions. Okay, let's see from number 1. Number 1, there is PCl4 positive. How's the diagram of PCl4 positive? Let's see this one. Okay, so PCl4 positive, as we can see here, there are phosphorus. Phosphorus has 5 electrons in the outermost shell. This one electron from the phosphorus is moving out from the structure. That means the ion become positive because there is one electron gone. And then so all these will form 4 bond pairs and 0 lone pairs or no lone pairs, and then the shape is tetrahedral structure with 109-degree angle. Okay, as we can see here, there are 7 electrons around chlorine. So this is the correct diagram of how to display the dot and cross diagrams. There has to be 7 electrons around each chlorine, and there has to be 4 electrons around phosphorus. Why? Because 1 electron is lost. Now let's continue to number 2. Number 2 is PCl6 negative ion. Negative ion means gain an electron. Okay, so let's see number 2. Here, number 2, here there are 6 chlorine. There are 6 chlorine, and then in each chlorine there are 7 electrons. This is electron which is gained from outside. This become negative ion. Let's see here, 1 pair, 2, 3, 4, 5, 6. So there are 6 bond pairs and without any lone pair. So the size of the angle is 90 degree, and then the shape is octahedral. Okay, when we draw dot and cross diagram, it should be like this. Okay, do we need to show like the shape of octahedral? Is not required, because in I level they expect us to draw dot and cross diagram like this to show how many electrons are around chlorine, how many electrons around phosphorus. Now let's number 3. Number 3 is sulfate ion, SO2-4. Okay, so we have to draw the diagram sulfate ion. Sulfate ion is like this one. Okay, so there are 2 double bonds between S and O. We know that double bond occurs because of overlapping of the S and P orbital of the same atoms. So these double bonds can be considered as a single bonds. So there are 2 electron gain. Which one? This one and this one. This one has 1. Let's count the oxygen, the electron around oxygen here. There are 8. 1, 2, 3, 4, 5, 6, 7, 8. Over here also the same 8 electrons around oxygen. So it means there are 4 bond pairs and 0 lone pairs. So the angle is 109 degree, 109.5 degree, and tetrahedral shape of molecule. Next, number 4. Number 4 is a nitrate ion. Okay, let's see how's the diagram of nitrate ion. Nitrate ion we have to draw like this one. So there are 5 electrons around nitrogen. And then which one are the electrons? The process 1, 2, 3, 4, 5. And then this one will form a double bond to oxygen. This one a single bond, and there is an external electron. Now this one is dative covalent bond from the nitrogen to the oxygen. That makes the oxygen has 8 electrons, and then here the nitrogen has 8 electrons also. And then therefore the number of bond pairs, there are 3 bond pairs and no lone pairs. The angle is 120 and the shape is trigonal planar. Next, nitrate ion, NO2 negative. Let's see the diagram. The diagram has to be drawn dot and cross diagram. Let's see here number 5, and there is a double bond with the oxygen. Double bond can be considered as a single bond because there is an overlapping of s orbital and p orbital of the same 2 atoms. And then there is an N here, and there is a lone pair and there is a bond pair with the oxygen, and there is an external electron in the oxygen that makes the ion become negative. So in conclusion, there are 2 bond pairs and 1 lone pairs. Okay, so the angle is 119 degrees. The shape is V-shaped. Now let's continue to this one, ammonium ion. Ammonium ion, as we discussed yesterday, ammonium ion, the drawing is like this. This one is dative covalent bond. Why? Because hydrogen doesn't have electron. So the nitrogen make a dative covalent bond to the hydrogen that makes this one become 2 electron around hydrogen and 8 electron around nitrogen, and then this one it carries positive charge. So in conclusion, there are 4 bond pairs and no lone pairs. So the shape is tetrahedral. The angle is 109.5 degrees. Next, sulfite, SO2-3. Let's see how the diagrams look like. The diagram looks like this one. So there is a double bond between S and O, and then there are 2 electrons from outside that make the electron of the oxygen become 8. This one 8 electrons, this one 8 electron, and there is a lone pair of the sulfur that makes this one there are 3 bond pairs and 1 lone pair. So the shape is trigonal pyramidal with 107 degrees. And then there is a CH3 positive. CH3 positive, this one is the diagram will look like this one. Okay, so there are 3 bond pairs because the 1 electron of the carbon has moved out, has undergo ionization. It lost electron, become positive. So there are 3 bond pairs and no lone pairs. The shape is trigonal planar with angle 120 degrees. So molecule and also polyatomic ions, they have shape and angles. But for the monoatomic ion does not have, and monoatomic molecule does not have. Example, monoatomic molecule is a noble gas like krypton, xenon, argon. There is no shape. And then the last question is CH3 negative. CH3 negative ions means it gains an electron. So it gains an electron here, it means gain electron. So here there are 3 bond pairs and 1 lone pair. 3 bond pairs and 1 lone pair is trigonal pyramidal with 107 degrees. Okay, so these are the discussion of today's worksheet. We are doing it online. We are going to see each other again on the next day with more discussion on chapter VSEPR and also chemical bondings in simple molecules.